Hey guys, welcome back. And in this video we're talking about generators in Python. I'm really excited for this section because we're going to talk about some more advanced stuff, and generators are one of these topics in Python that a lot of courses don't even mention, but they are essential for performance and also because the async development in Python, the asynchronous development that we're going to be learning later on, is built upon these generators. When you understand generators, a lot of things in Python start becoming a lot clearer. So what is a generator? A generator in Python is a function, but it's a special function. It's a function that remembers the state it's in between executions. So you can run the function multiple times and it will remember what it did the last time that you ran it. So that sounds pretty weird. Let me explain with an example. Imagine you wanted to build a list of 100 numbers. Very straightforward. You want to get a new list with numbers from 0 to 99, not including 100. So you could make a function like this one, obviously not using range and so forth, you know range. But let's not use range. Instead, let's build a list from scratch. How would you do it? A good way to do it would be to start with an empty list. Say, call it nums and make it equal to an empty list. And also start with an index equal to 0. Then while I is less than 100, say nums.append I. So you're going to append 0 at the start, then you're going to increment I by 1, which is going to make it into 1. You're going to append 1, repeat, append 2, then 3, and so forth, until you get to 99. And at the end of this function, return nums, which is your list of numbers. If we do print 100 numbers and we run that, we can see that it contains here our list of 100 numbers. Of course, we could use list comprehension for this, we could use the range function, but for now let's assume this is a cool way of doing it, because what I'm really explaining is essentially how the range function works on the inside. So we construct a list, fill it with the first 100 numbers, and then return them. Now we have 100 numbers in a list. This entire list is in your computer's memory stored as this return value of the function. Now, 100 numbers is not very big, it's quite a small amount of space. But let's say we wanted to store 10 million. Million is like 100 numbers, but it would be something like 1,000,000 numbers. You would generate a list of 1,000,000 numbers and store it in this variable that goes into your computer's memory, and it's presumably a bigger amount of memory that is taken because each one of these numbers is taking up a small amount of your computer's memory. If you wanted 10 million numbers, then it is bigger, and so forth. Now, having 10 million numbers, not a great example, but just imagine you had a very long list of something. For example, these are often used in calculating prime numbers and in big data and things like that. You maybe sometimes want big lists of things. So a generator is used to circumvent this problem, because the assumption is you don't need 100 numbers all at once. What you need is 0 so that you can do something with it, and then 1 so that you can do something with it, and then 2 so you can do something with it. For example, with this 100 numbers, we could then go and multiply them all by 2 and store them in another list. How would you do that? You'd do something like list comprehension, x times 2 for x in 100 numbers. What you're doing here is you're using this list to iterate over it and multiply each number by 2. Let's think that this multiplication by 2 is an operation that we want to do in these numbers in order to calculate something. Another example would be if you had a lot of users and you wanted to calculate the engagement around them or how engaged they are with your system or something like that. Essentially, you want to go over each element and perform an operation. But the thing here is you don't need all the elements at once. You need them one by one. So this is what generators are used for. Instead of having the entire list of elements, what you do is the generator gives you the first element of the list without storing all of the list in memory. The next time you call the generator, it remembers the element it gave you last, and it knows to give you the second element. And then you run it again, and it gives you the third element, and so forth. So it never stores the list in memory. It always only remembers the last number that it gave you, so it can then give you the next one. You have to run the function every time you want a new number, and that's why it's called a generator, because it generates numbers, or indeed strings or users or whatever it is that you want to generate. So here's how you would do it. Instead of nums.append I, you say yield yield I. For I is the number that we want to return. We no longer need this nums equal square brackets, and we no longer need the return statement either. So now this function here is called a generator function. Yield is very much like return, but what happens is it gives you I when you call it, and then it remembers that it's here, it's stopped right before line 5, right after line 4, there in the middle. Next time you call the function, it will continue. So what it'll do is it'll increment I by 1, it will rerun the loop and yield 1, give you 1, and then stop. Next time you call it, it will continue, increment I by 1 and repeat the loop and then give you 2, and then it will stop, and so forth. Eventually, when you run out of numbers, it will yield none. And then you'll know that it's finished. Okay, so how are we going to do this? Let's, first of all, print out 100 numbers. Notice how it no longer gives us a list, now it gives us a generator object, which is called 100 numbers, that's the name of our function, and then it also gives us the memory address of our object. Notice how we defined a function, but the print is telling us this is an object, because Python in the background realizes that you've used yield, you're making a generator, and it turns this into a Python object. I'll tell you how to make these objects yourself without a function later on. So let's store our generator in a variable. I'm going to call it G. That's a fairly popular name for a generator in a small program. If you have many generators, of course, you'll have to go for a more descriptive name. And then we're going to print the next value that the generator would give us. Notice that when you initialize a generator, like so, it doesn't run the function. It starts at the very top without running at all. And when you ask it for the next value, it will run up until the yield and give you whatever value you've yielded. And the way you ask it for the next value is you don't run the function again, but you say next of G. So next is a built-in function that affects generators, and it tells it to go up to the yield. Okay, so if we run this, you can see now we get 0, because that's the very first number yielded. Now, our generator, G, has stopped here at the line 4.5, between 4 and 5. So if we ask it for another number, notice that, of course, at the end of our program, the generator is destroyed. So if we run this program again, this will be 0 again, and this will be 1 now. It doesn't remember it across program executions. That's just not how Python works. So now we can ask it for the first number, and then for the next number. After the first number, it'll be stopped between 4 and 5. Then, when we say next, it continues up until the next yield, which means repeating this loop once and gives us 1. Okay? Very important. The function remembers where it stopped. So at any point, you can stop the function from running, and then you can call next in order to continue it. So it's not useful only for, generating numbers or whatever. It's also useful when you want to stop a function from running temporarily, and then you can continue running it whenever you want by calling next on it. So that's maybe not something that makes too much sense just now, but just remember that, for we will need it when we do asynchronous programming. So what about the range function? I said earlier that this was explaining essentially how the range function works on the inside, and that's true. But the range function doesn't give you a generator directly. Here, let's do something like my range object. It's going to be range 10. This behaves very much like a generator, but if you call next of myRangeObject, you get an error. And look at that. And that's because the range object isn't quite a generator, even though it behaves in this way. It doesn't generate a list and then allows you to iterate over it. It behaves in this generation-ish manner to be more efficient. myRangeObject, though, you can remember that we printed it out much earlier on in the course and we received some weird range 0 to 10 thing. That's just the repr function being called. And as you can see, if we print out the repr outcome, we also see range of 0 to 10. So myRangeObject is something that behaves very much like this. We're going to learn in a couple of videos' time exactly how we can iterate over an object in order to make it behave like the range object. So we've learned about these generators, and one more thing I wanted to mention actually about the generators is the list function can turn a generator into a list. So we can print list of G. Notice here how we've called next, then next again, and then list. So now we have 0 and 1 printed out, for those are the two things in our next functions, and then we've generated a list of the generator, but that list of course continues from where we left off. The generator itself remembers where it was, so then the list starts from 2, not from 0. So it's really important to remember in generators, they remember where they were. So when you create one, that's it. From essentially the moment you start using it, the moment you start calling next on it, it remembers where it is and you can't go backwards. Okay? Now, in the next few videos, we're going to learn more about generators. We're going to learn about generator classes, how you can create a class that behaves like a generator. And we're also going to learn about iterators and iterables in Python, and the range object is one such example. Then we're going to move on to some functional programming examples like filter, map, any and all, and enumerate. So pretty excited for this section. I'm confident that generators are going to be something that you are going to need in your Python development, particularly as we move on further in the course. So with that said, I'll see you on the next video.